Hello and welcome to today's episode of the FIWARE Data Space onboarding session. Today I will talk about how to deploy a FIWARE Data Space connector. My name is Stefan Wiedemann. I'm Senior Software Engineer at FICodes. Probably some of you already know me from the presentation about decentralized identity and access management in a FIWARE Data Space connector. I will refer to some of this stuff today, but it's not really a precondition that you have seen it. It might help to understand some things better. Okay, let's have a short look on what we want to do today. I will start with some, let's call it preconditions. So essentially what we expect to be in place before we start to deploy the FIWARE Data Space connector. Then after this, let's say more theoretical part, we will go to the interesting parts of actually deploying a FIWARE Data Space connector. First by setting up the trust anchor, then deploying a data space connector for a consumer, then deploying a data space connector for a provider, and in the end also verifying the system. The idea is that after the presentation, every one of you should be able to set up a data space connector according to your use case and also verify that it's actually running. Okay, then yeah, let's start with let's say recapitulating what the FIWARE Data Space connector actually is. As most of you hopefully now already know, the FIWARE Data Space connector is using microservice architecture and is therefore assembled by a couple of services that together then form a data space connector. So we have a couple of components for authorization. We have some components that have to take care about the authentication. We have components for data transfer control. We have some contract management and catalog services, and we obviously have our data services. All of those components can be enabled and disabled independently, very much depending on the use case you're having at hand and what you actually need from your data space connector. One of the goals of the FIWARE Data Space connector was to actually reuse existing open source components. So we did not want to re-implement the wheel, but rather rely on components that they're already well maintained, well developed, and established in a number of systems, and just implement the components that are more or less missing to fulfill a full data space connector. And another thing that we also had in mind when we were building the data space connector and its, let's say, deployment recipes is that since it's an open source component, we have to support various target environments. So be it a public cloud environment, be it an on-premise system or some hybrid cloud system where you have something running in the cloud or on an on-premise system, or even some, let's call it more edge systems where you have a restricted level of resources. Now, what requirements does this give to our deployment recipes? Obviously, we need some solutions for the internal and external networking. In every microservice architecture, you have the problem to solve on how the services can find each other and how they can address each other in a standardized fashion. This is what I would call with internal networking. We also obviously need some external access to our data space connector, because if, let's say, a data provider wants to offer its services, somebody has to have the ability to reach it through the public internet. So we also need to support that. Then obviously, we have to have support for configurable deployments. We want to have this modularity of the data space connector. Therefore, we also need this on a deployment level. Sorry, can you please mute each other, everyone? Somebody is not muted. Okay, thank you. Therefore, we need some support for configuration of those deployments. Beside that, we also want to integrate not only the open source components itself that are already existing, but also their deployment recipes, because essentially everything that already exists and is well maintained reduces the maintenance work for ourselves, but also improves the overall quality of the data space connector, because we then can rely on already production tested recipes. And as the last point, which is important, especially to support different environments, we need a certain level of abstraction of infrastructure. So we cannot really provide data space connector deployments for every single different target environment. Therefore, we need to abstract them away, provide one that is feasible for mostly all of them, and therefore they can just connect through the abstraction of the infrastructure. Okay, how did we decide to solve that? Most of you already know that. The FIWARE Data Space connector, let's say default deployments, are targeting Kubernetes as the container orchestration, and we're also using Helm for our deployments. Why do we use Kubernetes? Obviously, because of the requirements I mentioned before. It allows us to abstract away the infrastructure through standardized APIs. It supports the internal networking that we want through its software-defined networking. It provides various options for external access to the cluster, which is somewhat easy to control and configure, and which also is a lot of documentation available already in the internet. Kubernetes is an open source component and well maintained. It's a part of the CNCF graduated program, so it's used in various production environments and can just be trusted. And there are also various managed or self-hosted options available to actually use Kubernetes. And we also use Helm, which is essentially a package manager for Kubernetes deployments. It allows us flexible configuration and configuration management. It also relies on well-established tools like Mustache, for example, in terms of templating, and principles like providing same defaults, only override what is required to keep the actual configuration small, or a proper dependency management. And like Kubernetes, it's also an open source project, which is part of the CNCF graduated program. Therefore, it's also something that really can be trusted in production environments. Just a couple of more words to Kubernetes for those that don't know much about it yet. So Kubernetes is an open source container orchestration platform that automates deployment, scaling, and management of containerized applications. It supports different environments such as on-premise data centers, public clouds, and hybrid setups. We already can cross a lot of buzzwords here already that we had in our requirements. But just to summarize again, Kubernetes brings us service discovery and load balancing so that the individual microservices can connect to each other, and that we can balance the traffic through them, not only through the services, but also through the whole cluster, depending on the load. It provides us some self-healing and restart capabilities of the containers and services itself, so that we can increase the overall resilience of our system, which is quite important for microservice architecture. It abstracts away the infrastructure, most notably the computation, the storage, the networking, and therefore allows us to reuse the same recipes in different environments. Yeah, and that's just well established and widely used, so you can find documentation everywhere about it. You can also find essentially people that can do it for you. So it's not, so let's say, a niche product, but it is more or less an industry standard already. Similar about Helm. So Helm is a package manager for Kubernetes that simplifies deployment and configuration of applications and services. It uses pre-configured templates of Kubernetes resources, enabling users to define, install, and upgrade their application. What does it mean? So a Helm chart essentially is a set of Kubernetes resources that are provided as Mustache templates. That means the usual resources that you know from Kubernetes, so let's say a deployment YAML, a service YAML, etc., is extended with the capabilities of Mustache, which allows to replace values inside those template files. A Kubernetes chart contains defaults, always with the target to allow install in a standard fashion with very minimal additional configuration. That will help us trim down the configuration that we need in our actual data space connector when we deploy it. One important thing for us is that it also natively supports versioning of the recipes. So you can install a certain version of the Helm chart instead of running into a risk of basically getting incompatible updates when you reinstall a chart. It also allows us the reuse of existing charts as dependencies. So if we want to reuse a component, like for example Keycloak as part of our data space connector, we don't have to write our own Helm chart and deployment recipes, but instead can use existing ones as a dependency. And it also supports repackaging of a set of charts to umbrella charts, which is something that is very important for us and what we heavily use for the data space connector, as you will see in the next minutes. Now, some additional operational considerations, which I will just mention now, because that's not really in the scope of deploying the data space connector. But it's always important in terms of actually operating your connector or essentially every service that you have. So for monitoring, data space connector components provide endpoint, for example, Prometheus scrape endpoints so that you can integrate it in some kind of standard fashion monitoring. Due to the use of Kubernetes, you could also get all the standard resource monitoring or resource usage monitoring that you're probably already used to. And in general, you should just integrate it with your existing monitoring. So the data space connector itself doesn't have specific requirements for monitoring. It just tries to offer the standard capabilities of, let's say, modern microservice architecture. More or less the same is true for logging. One point is that the log levels can essentially be configured for each individual component of the data space connector, which is quite important because due to the number of microservices, it could become quite noisy if you just change the log level on a global level. Essentially, all components support structured JSON logging, so it could integrate with most of the standard log aggregators. And as the monitoring, you should just integrate it with your existing logging. And yeah, I somewhat repeat myself. Alerting is very similar. It should be just based on the monitoring logging that you did set up, and you should integrate it with your existing systems. There are no really additional requirements for data space connector, but you could use tooling like a service mesh if you have such concrete requirements, for example, to apply mutual TLS inside the cluster. But that's something that is very individual to the use case you have for the data space connector. Okay, now that we did somehow set up the preconditions, I would say, I would go into the more or less details of the FIWARE Data Space connector. We have essentially one single deployment recipe for the FIWARE Data Space connector, which is an umbrella Helm chart called the Data Space Connector Helm chart, which is more or less just assembled by charts from the FIWARE Helm charts repository and the Bitnami Helm charts repository. In the FIWARE Helm charts repository, you can mostly find the components that were developed and are maintained by the FIWARE Foundation and FIWARE community. And in the Bitnami Helm charts repositories, the Bitnami Helm charts are one of the biggest open source repositories for Helm charts available. And it contains a huge number of charts for, let's say, some of the widely used open source components that you can find in various microservice architectures, like, for example, Keycloak or various databases. We decided to use all the charts from that repository because it makes it easier from a configurational standpoints. They all follow the same principles. They are all well maintained, and so it makes it easier in the end to understand the configuration of the data space connector and its subcharts. If we just use two of those two Helm repositories instead of using, for example, individual charts for each open source component. The umbrella Helm chart is extended with some convenience functionality that just makes it easier to configure the data space connector. It allows us to disable all individual subcharts to actually have the modularity that we wanted. And you could also exchange individual parts of the data space connector, like databases or API gateways. We do automatically test the data space connector on each change in a K3s cluster. We also tested it on, I call vanilla Kubernetes environments. It also contains support for OpenShift installations. Yeah, so it's, let's say, very flexible. And we also have a minimal chart for a trust anchor contained in the repository so that we can actually set up a full data space just with the charts that we provide. Now let's take a short look to the concrete chart repository. In the end, it's only a GitHub repository which contains two folders, one for the trust anchor and one for the data space connector. Let's have a look into the data space connector chart. This is the standard layout that everyone who knows Helm already knows, but it's in the end the standard layout of a Helm chart. It always contains a chart YAML, which contains information about the chart itself, a values YAML file, which contains the default values for our chart, and it contains a templates file, which contains the actual Kubernetes resources with the templating inside. Let's have a look how this templating, for example, looks like. So we have the standard standard fields of Kubernetes resource, like its kind, device version, etc. And then we have the mustache templating, which is in the end then replaced from the values inside our default values or from the configuration that we provide on installation. More important for the data space connector is the chart YAML, because as I mentioned, it's an umbrella chart, which is in the end only assembled by various already existing components. And we just pull them in as dependencies. So we have a list of dependencies here, like for example, a Postgres database that can be configuratively enabled or disabled, and we tell the repository where it's pulled from. So this is like most in the style of most other dependency management systems, be it Maven, NPM, or whatever you think about. You define where to pull the dependency and in which version you want it. That's what we also do here. If you go through it, you will see everything comes either from the Bitnami charts repository or from the FIWARE Helm charts repository. I will go through the details of the subcharts later in the presentation. Now that we have an idea about the data space connector itself, I want to recapitulate what the data space actually looks like in FIWARE. Most of you hopefully already know this picture from the IAM session. So we have a data space is formed of various participants in different roles, like a data provider, like a data consumer, or a marketplace itself. And the difference between those participants in the end is just what parts of the data space connector they have running and what they want to achieve with the data space connector. A data provider usually wants to serve some data to participants of the data space. The data consumer usually just wants to access data. And all of them needs to have some kind of a trust relationship, which is basically the verifiable data registry or multiple of them. That they put trust into. And the verifiable data registry is what we have here as a trust anchor, Helm chart as part of our deployment here. And therefore, we also will start now with the deployment of the trust anchor, because essentially just deploying a data space connector without being connected to any trust anchor doesn't make sense, because if you don't have a common trust relationship, there is nothing you can do for your data space connection, or you don't have a data space in the end. Okay, now let's start with the trust anchor. A trust anchor is relatively easy in the way that we deployed here in our FIWARE Data Space connector part, or in our demo data space, I would call. It essentially only has to provide two functionalities. One is provide the global trusted participants list through the EPSI Trusted Issuers Registry API, which is something you might recall from the IAM session, where every participant can check if another participant is also part of the data space. And we also need the functionality to actually register new participants. So if somebody wants to join our data space, we also need the capability to add it to the global participants list. That's the requirements that we have to our trust anchor, and that's what we first have to solve here. Now, from a deployment view, how do we solve that? We install the FIWARE Trusted Issuers list, which actually provides two APIs. One is the EPSI Trusted Issuers API that we require for our participants to check if another one is already a participant, and which also offers the so-called Trusted Issuers List API that we implemented for registering new participants to our Trusted Issuers Registry. In addition to store the information about those issuers, the Trusted Issuers List uses a MySQL database as a storage backend for the participants. You can either deploy it as part of the connector. You could also use the database as a service offering somewhere. But in this demo today, we will just deploy the MySQL together with our Trust Anchor services. Okay, then let's go to the first part of our deployment. What I already prepared today is a cluster that I can use for deploying. That's actually an installation of a K3s cluster because that's just faster and more reliable for a demo. But overall, you could use the exact same recipes to deploy it to essentially any other Kubernetes cluster. Let's have a first look on what we have running inside this cluster. I hope you can. It's big enough for you to see. So this cluster is pretty standard right now. We have a core DNS running to have our central, our let's say cluster internal domain DNS available, and we are using Traffic here as an ingress controller. But we also not just bound to Traffic. You could also use an Nginx, an HA proxy. You're still seeing the slides. That's not good. Then let me. I thought I'd share my screen, not only the entire screen. Sorry. Now you should see it. Okay. Sorry. Thank you for mentioning it. Okay. So now, then again, you can see here that's what we currently have running in our local system. That's the cluster internal domain DNS system, and this is our ingress controller. Nothing more running yet into the cluster. One thing that I will also install, which makes our cluster more, let's say, realistic, is a storage provider. That's something that you have essentially already installed in every Kubernetes cluster. So I use a local storage provider here, which allows the Kubernetes cluster to store something on the local disk. If you, for example, have a Kubernetes cluster running in Google Cloud, you will already have stuff like an HTTP storage provider or an SSD storage provider that you can just use for everything that you want to store. That's something that's more cluster related that you should, in the end, talk about with your cluster administrators. Okay, but now to the more interesting parts. How do we deploy our Trust Anchor? As a first step, we will have to add our FIWARE Data Space connector repository as a repo to our local Helm installation. Doing this is essentially one command, which is Helm repo add. Then we can add the name of the repo that we want to add, and we have to give its address. A Helm repository itself is more or less just a YAML file which contains the names of the charts, the version, and where to find them. And all of this is then resolved internally by Helm itself. Now, let's add this. Okay, I already have it installed in my local system. And then we can move to the Trust Anchor folder. Which at the moment only contains a values YAML file. This values YAML file actually contains our specific configuration for this installation of the data space connector. It has to follow the format of our default values YAML. The default values YAML usually also contains the documentation for it. And we only have to provide the values here that are actually different to those that are already in the default YAML. I actually made this one for Trust Anchor a little more verbose to give you a better idea about the actual contents. But in general, they could be quite small for the data space connector because we could just leave the defaults out. We start here with an entry which is called generate passwords. That's something very specific to the data space connector, since we're connecting a lot of components and they only have to communicate internally, like for example the database and the application itself. We enable the generation of passwords for example, the database connection inside the cluster. So the passwords do never have to leave the cluster in that case, which is quite easy or quite comfortable to keep the passwords secure, because if they don't need to leave the cluster, you don't have to store them anywhere else. If you use that, they are already distributed to the MySQL and to the trusted issues list through their default configuration. If you don't want to do this, you could also use some mechanisms like existing secrets, or like something like a vault that injects the secrets inside the cluster. That's highly flexible, but for such I would say advanced configuration, you should always try to consult the chart or the original chart itself. In this case, the Bitnami Helm chart for MySQL. The MySQL itself is the second component that we can see inside this YAML file. First, we actually enable it, so we want to deploy it as part of our Trust Anchor. And then we have the one configuration that we actually need here. We have to set the storage class for the persistence of the MySQL. We use here the local path storage that I installed for this cluster. But since the storage classes are quite related to the cluster itself and what's available in the cluster, you most likely need to set a storage class for your cluster here also too. And it might be something different than local path, but yeah, as mentioned, that depends on the cluster. Okay, then I inserted here some of the already existing defaults. This is something you usually don't have to provide here, and I left it out in the other values files that you will see later. But those are some of the configurations that are set for our Trust Anchor here. Like, for example, we give the MySQL, let's say, a stable name so that we can address it from our trusted issues list. We reference the generated secret. And we also provide a script that initializes the default database schema that we want to use for our trusted issues list. Now, with that configuration for the MySQL, we also need the actual configuration for our trusted issues list. Similar to the MySQL, we have to enable it, or essentially they are enabled by default, but I think it's more, let's say, easy to read if you explicitly also enable the components, because then you have a better view on the actual configuration of your data space connector. Then, because our trusted issues list should be available to the other participants in the cluster, we need to configure an ingress. The ingress is basically the configuration of the public-facing addresses of our database connector. And it's best practice in the Kubernetes world and in Helm charts to disable ingresses by default. Therefore, we have to explicitly enable it here. It's disabled by default usually because it should prevent you from opening services to the public internet without being aware of that. This follows the standard way of configuring ingresses in Kubernetes. So you define the host here and the host address. I use an internal libio address here so that I can use it from my local network then. So on this address, the Trusted Issues Registry API will be available. And to allow us also the configuration here through the Trusted Issues List API, we also enable this ingress under a different address. And generally, you could also configure TLS for your hosts here. But since I'm running it locally and I don't have a valid certificate installed here, I don't configure TLS, but all the charts obviously also support configuration of TLS. Similar to the database, I included the defaults here, which is mostly also giving it a fixed name to be addressable by other services, and then configuring the database connection. If you use the defaults for the MySQL and for the trusted issues list, you can completely leave this out. But just to be to make you aware of the options you have, you can configure this to be persistent or even run it only in memory. Then you configure the name of the database user. You could provide the secret that actually contains the database passwords. We have to provide the host of the database also as part of the default configuration, and also the name of the schema to be used by the database configuration, by the trusted issuers list. Now, with that values YAML files, we can start to deploy our trust anchor. We could use directly Helm install here. Then it will use the data space connector, the chart, render the templates to actual Kubernetes resources and apply them to the cluster. For debug reason, sometimes it helps to actually render them locally, which is something I will now do here. So we say Helm template. Then we refer to our data space connector repository and to the chart that we want to install, which is the trust anchor. We also say we want version 220, which is wrong. It should be 020, sorry. So we want this version of the trust anchor here. Then we hand over our values YAML file that I showed you here, which essentially overrides the entries of our default values YAML. We provide a name template so that all of the resources follow a certain name standard, and we tell that this should go to a certain namespace inside our cluster. Now, if we do this, we will end up with the rendered templates inside this folder, where you can see the MySQL chart and the trusted issuers chart rendered out. And it will contain the actual Kubernetes resources that will be applied to the cluster. Who's familiar with Kubernetes will probably recognize them already. So this, for example, is a config map which follows our name schema, which contains a certain number of contains the namespace, and then essentially the configuration that our MySQL will use. It's very similar for the trusted issuers list, where we have the deployment, which configures our trusted issuers list container and tells which image to be used. It also tells where the image actually is accessible. So under 8080 for the HTTP port, for example, it provides some health and liveness checks. And then, for example, the configuration to our data space. All of this is now automatically put in from within the values file. Similarly, you can see here with the ingress configuration that I talked about. So this will create an ingress to the cluster, which then will be evaluated by the ingress controller and be made available to the public internet through our Kubernetes cluster. It tells essentially to use this host and make available this path and forward it to the service of our trusted issuers registry. Okay. Now we obviously also have to apply it to the cluster. I will create a namespace for our trust anchor so that it's easier to separate inside the cluster and see. So to now create the namespace trust anchor inside our cluster, but that's mostly depending on how you want to organize your cluster. So you're free to do whatever. We could even now apply the rendered files, or we could use directly Helm to install the data space, the chart into our cluster. The command is essentially the same like you have with Helm template. You provide the name of the deployment you want to make, You reference the repository and the actual chart inside it. You have to provide the version, and then you offer it the values that you want to use with it. Now let's install it. Okay, I'll make this a bit bigger so you can see now this is starting to install, and we now can take a look that it actually is going to be installed inside our cluster. What you can see here is that it first has to deploy the MySQL to be used by the Trusted Issuers registry, which is the reason that our Trusted Issuer itself is still in a crash loop, because the Trusted Issuers registry can only start once the MySQL is available. That's not unusual for a Kubernetes system, that you just let the service restart until the database is available. So I think after about 60 seconds it will be available, and we will have our Trusted Issuers registry available once all of this has resolved. In order to save some time, I will now switch back to the presentation, because we have two other charts to deploy to have our actual data space running. The second one is the actual data consumer. The consumer itself is, in contrast to the trust anchor, really a participant of the data space, and will have to install its own installation of the data space connector. As a consumer, you don't have too much responsibilities inside our data space. If you want to access data of another provider, you will have to the ability to authenticate yourself and then go to the data. So what we need to fulfill this is an issuer of verifiable credentials that could provide the credentials to our users or services, which will most likely store them in some kind of wallet. And we also will need our organization to be registered at the verifiable data registry as a valid participant, which means we need to register ourselves at the trust anchor we deployed right now. How does it look in an actually deployment? In the FIWARE Data Space connector, we're using Keycloak as the default issuer for verifiable credentials. We are using version 26 here, and I think everything above should be able to use in the future too. The Keycloak needs a realm to be configured for OID for verifiable credentials issuing. We need some users and roles configured, and also the credentials that it should issue. What we also need as part of our deployment is obviously a database for Keycloak. Keycloak by default uses a PostgreSQL, which in our current demo we will also deploy as part of the cluster. But you could also again use database as a service here. One important thing is that we as a consumer organization also need an identity and some key material for the organization. And we need to provide the identity to our verifiable data registry and register ourselves there. And we need to provide the key material to our issuer so that we can identify ourselves. If you remember from the IAM session, the data space connector currently supports 3 types of identity: DID-key, DID-web, and DID-LC. And since we're now deploying here a local example, I will use a DID-key for the consumer organization, which is essentially the first thing that we will now do to deploy our consumer. As you can see here, now everything is running. We have a working trust anchor available. And now we will switch to our consumer. I will also create a namespace again for our consumer. And then I will first start with creating an identity for our consumer. Creating the key essentially means we generate a private key and a public key for it. We package the public key into a key store so that we can support the key store to our Keycloak so that it can be used for signing the credentials. And we will also create the actual key, DID-key, from the public key so that we can use it as our identity for our consumer. I will just follow the steps that I noted here. You can read all of this also in detail later, so I will not go into all details. But first we have to create a private key You can see all of them here. So we have the private key here. Then we will create the public key from that. Public key. Now we will create a certificate based on that for our participant. And now we will take all of this and package it into a key store that we can use for our to provide the secret into our cluster later. Now we also have to create a DID key from this from the public key we created here, which follows a very standardized way of encoding of a base 58 encoding of the key, which is then also prefixed with a key type. In order to make this a little easier, I created a little tool called DID helper, which can be used for that. I will download and use it here. So we just provide the key store and the password to this tool, and it will create a DID key that works together with our private key and with the public key. We now have to remember this key when we configure our consumer itself, because our consumer needs to know its own identity. As a first step to actually deploy our consumer to the cluster, we have to provide the secret that we created, so our key store, which contains the private key for our consumer, to the cluster. We will do this by creating sorry by creating a secret inside the cluster from this file, from our key store file. So the secret inside the cluster will then contain this this key store. This is the kube control command that we use for it. Consumer identity will be the name used for this secret, and we also tell to deploy it to our namespace consumer. This is a very quick command, so we do it here. And now we have the secret inside our cluster. What we now have to do is to configure our data space connector for the consumer. As you've seen, there is not much, let's say, flash on the consumer, so we only have the issuer. Therefore, we can essentially enable all other components from the data space connector. So we disable the verifier and its the components it depends on, like the config service and trusted issuers list. We configure all the we disable all the components are used for authorization. We disable the data service because we don't want to offer data. We also disable the team form APIs and the contract management because, again, we don't want to offer any data, we just want to consume it. Then we come to the components that we actually need. Our key cloak as an issuer obviously needs a database because somewhere there needs to be information stored about, for example, our users. We deploy the PostgreSQL here. You will see that this looks very similar to the MySQL configuration that we had before. And that's one of the benefits of using the charts from one single repository. So all Bitnami Helm charts essentially follow the same style of configuration. So no matter if we configure the Postgres or the MySQL, setting the storage class is more or less always in the same fashion. So we set the storage class to a local path here again. And that's essentially all configuration that we need for our PostgreSQL. Everything else is taken from the defaults of the data space connector. As a second step, we have to configure our key cloak, which is probably the most, I would say, most complex configuration of the whole data space connector, to act as the issuer of credentials. First, we have to configure the ingress to the key cloak because obviously our users should be able to access it and download their credentials from it. So we configure it to run under the hostname keycloak consumer 127.0.0.1.io, and we configure the connection to the database. This actually is a default configuration which could also be left out. you could, it also doesn't hurt to just put it in here. Then we configure a couple of so-called extra environment variables, which are quite important for our Keycloak to properly work. We want to import a realm on default because we actually, so you could configure your Keycloak also through some front ends, but especially configuring the OpenID for verifiable credentials issuance features is much easier if you first configure them through the JSON interfaces. This is a quite new feature of Keycloak, so it's not very well integrated already into the front ends. Therefore, we are using the import realm feature of Keycloak, which has to be provided as an extra argument. And the data space connector itself provides some already existing templates for setting up the realm. You will see how to configure that in probably 2 minutes. Then we have to actually enable the OpenID for verifiable credentials issuance feature, since it's currently in the experimental stage in Keycloak, and therefore has to be explicitly enabled. It will probably become a preview feature with the next Keycloak version, and then hopefully a full feature within 28, 29 version. But yeah, at the moment it's a preview feature and needs to be explicitly enabled. This is a configuration that also depends on how you run your cluster. It's very common to terminate SSL in a Kubernetes cluster at the edge on the ingress controller, and that's something that we have to tell Keycloak because else it would drop every non-HTTPS connection and therefore won't work inside our cluster. Then we provide the password of our key store here. So Keycloak needs to be able to open the key store that we provided as a secret to the cluster, and we need to provide the store password somewhat here. In the demo, I used the plain password here, but you could also provide the password as a secret to the cluster and then just reference it essentially the same way that we do it with the admin password here. Then to give some impression of how to configure the log level in Keycloak, you could set this here, and I did set it to info. In a production environment, you most likely will rather have something like more instead to not flood your log files essentially. And we have to tell Keycloak under which host name it runs. And then there is the configuration that we always have to set, which is the actual identity of our consumer. So this will be used to this will be used as the issuer of the verifiable credentials. So that's why we have to create the identity first. We have to properly register it, and then we have to provide Keycloak with this DID so that it can use it as the issuer of the verifiable credentials, and our users can actually authenticate themselves at other participants. We have some additional configuration here that more or less only mounts the secret into Keycloak, and also the realm that we will configure in the next step. This is more or less standard and does not need to be changed most of the time. Okay, now have a look on how the realm is created. So as mentioned, it's not you don't have to do it that way, but I highly recommend it because it's much easier than trying to do it through the APIs and through the front end. We have to tell the realm under which address the Keycloak is running, because else the front ends won't work. So we have to provide our public address here. And our realm has to have a name, like every realm in Keycloak. So if you're not familiar with Keycloak itself, I can recommend to read about it, or essentially just accept that we have to give the name here. And then we configure, in our case, client roles. So more or less, which roles do we as a consumer want to assign to our users? I define 2 roles here. One is reader, the other is operator. And in this example, we are using the DID that we configure, so our identity, also as the client ID, which could be done through environment variables. So every environment variable that we provided as an extra env could be used as part of our realm configuration. Thus, if I set this as the ID, it will be replaced with the ID we provide as an environment variable. Once we have the roles configured, we could also configure a user to be deployed as in our Keycloak. I just use one test user here. That actually got the Yang test user and is enabled by default. It has an email and a name like typical. It also has a password, which I provide in this case as plain text. There are different types of providing credentials, but that's something you should read in the configuration of Keycloak. And we give it a role inside our client. So actually our test user will get the role operator. That will be interesting later when we actually get a credential for our user. And then we have to configure a client itself. The client is the one that then issues the credential to our users. Most of it is standard configuration available from Keycloak, so you could just copy it. One very important thing is to set the protocol to OID4VC here, because that enables the realm to issue these credentials itself. And then we will create the configuration of our verifiable credentials. This realm itself supports 3 types of credentials. One is the user credential, the verifiable credential, and the operator credential. All of them have a credential ID, which is set at the second point of the key. And they will have a format. We currently only support JWT, or we only use JWT verifiable credentials as part of our data space connector installation. So we only set the format for that. And then we can use the protocol mappers to actually configure what should be included in the credentials. We have, for example, a target role mapper, which would set the roles of our user inside a credential of type operator credential. We could also configure which context to be set to the credentials. We could include information about our user into the credential, like the email address or the name or the last name, so that we can very fine-grained configure what to be put into the credential. I just can recommend to read the documentation of Keycloak about that part, because you have a high freedom of configuration here, but it could also be a little complicated. I can tell you that this is currently under, let's say, gets overhauled in the next version of Keycloak, and will be much easier in future versions. But this is still under construction, I would say, in Keycloak itself. Okay, but that's essentially all the configuration that we need for deploying our consumer. And the deployment itself follows the same way that we used in our data space in the trust anchor. The only difference is that we now address a different chart inside our repository. So the repository is still the data space connector repository, but we now actually take the data space connector chart. The version that we want to have installed is the 7.17.0, and we want to provide the values YAMLs that we have for our consumer here. Now, let's install it. Same way as we had before with the trust anchor. Okay, now have a look at this. Similar as we have with the trusted issuers registry, Keycloak will probably fail once. Maybe it's slow enough. But Postgres has to be available first, and then Keycloak will be available after 50 to 60 seconds usually. One thing that we can already do is actually register our consumer at the trusted issuers registry. As you remember from Trust Anchor, we opened up the trusted issuers list endpoint. And in order to become a valid participant, we now have to register it there. This is publicly available here for the demo environment. How somebody gets onboarded actually to the Trust Anchor is something that the data space needs to be decided upon. So that's not something we really could define beforehand. We will give some recommendations or some ideas on how to do it on Thursday in the ongoing work session. But for today, we just do the curl the post command to the trusted issues list to add actually our new consumer, or our new participant. I have to use the ID here, or it won't work later. So we will create it here. And now we can check that it's actually part of our trusted issues list. Make it a little nicer. Where is it? Oh, it's not very readable. Okay, I can. And I don't have the prettifier now here. Sorry. But you can see from the result here that our new DIT key is now involved in the trusted issues registry, so that all participants can check it there. Now let's take a look if the key cloak is running. It is. And now it should be also available through our public endpoint, which we could access here. Okay, there is key cloak starting. We could, it's probably a little small. We could open it, log in with the test user, and actually try to get credentials. So, looks good. Now we could also try to actually get a credential. This is something I would now do through the REST API, because that's more or less easier than to do it with an actual wallet and integrate it into our local environment here. So we are following the rest here. In next week's session, I will go more into the details of what this script here does, but it essentially follows the OpenID for verifiable credentials issuance protocol and will retrieve a credential from our KeyCloak consumer here. Now we can see this is our credential, and let's check its contents, that actually it contains what I promised. Okay, we can see here that it's issued by our consumer. We can see that it contains the type that we did set up, so the operator credential. We can see that it contains the information of our user, so it's called test reader, and that it has the role that we did set up for the operator. It also contains the email. So it's essentially the credential that we configured in our realm, and we were able to extract it for our test user and store it in its, let's call it, local wallet. Okay, now that we have a consumer, we have to go to the, let's say, complicated part or more complicated deployment of the provider, because the provider itself requires a couple of more services, since it wants to offer actually services to, for example, our consumer here. What does it use? What does it require for that? We have to have the authentication services to offer actually the OID for verifiable presentation endpoints, so that our user or our consumer can authenticate itself with its verifiable credentials. We need the verifier here, as mentioned. Then the verifier requires this trusted issuers list, its local trusted issuers list, and the credentials config service to get its authentication configuration. And it needs to be registered at the verifiable data registry and connected so that it can check who are the participants. We need the authorization services, policy enforcement point, decision point, and administration points to actually enforce and manage policies. We need a data service to actually offer something. We need the Team Forum API and the contract management to offer our services. And we also need a data space config through a well-known endpoint to fulfill part of the IDSA protocol. So you could essentially check at the well-known endpoint what your data space connector provides you for the data space. How do we do this? First, authentication. We use the VC verifier, which is built and maintained by the FIWARE community to offer the OID for verifiable presentation endpoints. We also provide two services called Credentials Config Service and Trusted Issuers List, which I talked in the IAM session a little more about, which are also maintained by the FIWARE community. They have to have their storage backend. It could use the same instance because both of them use MySQL. just with their own with their own schemas. You could also use a database as a service here because that's a very standard MySQL. And similar to the consumer, we have to provide the identity and key materials for organization to our internal services, and we have to register it at the verifiable data registry. Authorization. For authorization, we are using essentially two already well-established open source components. The central entry point to our provider, to our data space connector, is an API gateway called API6. API6 is an API gateway maintained by, I think, mostly maintained by Red Hat. And it acts as the PEP for us, but we also use its routing capabilities to offer the OpenID configuration endpoint from our verifier, and also the data space configuration endpoint from a static file server, so that we could fulfill the, let's say, contract of the data space to provide the authentication and information, and also the data space information. API6 also checks JWT tokens that it receives from a user at the verifier's JWKS endpoint. Beside that, the PDP looks a little different here in our deployment view because we deploy the PDP as a sidecar to the PEP, so that they run inside the same pod. That gives us a little more performance and makes the deployment overall easier. The PDP is the open policy agent, which is also a well-established standard component that we just reuse here. For policy administration point, we have our ODRL PEP, where you can manage the policies, and they are stored in its storage backend, which is actually a PostgreSQL database. Again, you could also use a database as a service. And our data service in our demo environment is an NGS IID context broker. Obviously, since we're a FIWARE, the data service could also be anything else, but we are using an NGS IID compliant broker here. We use Scorpio as part of our data space connector deployment. And this has to be provided with the PostGIS as a backend. I currently don't know about database as a service solutions for Scorpio. Maybe somebody knows more about it. But it's essentially a Postgres with the PostGIS extension. And that's something that Scorpio just needs to store its entities in. And as the last part of the provider, we also want to have the TM-Forum APIs available so that we can offer the marketplace and contracting functionalities. The TM-Forum API that we use, implementation that we are using here, actually uses an NGS IID context broker storage backend in a data space connector deployment. We usually also just reuse the Scorpio we already have and store the TM-Forum API entities also there. The TM-Forum API endpoint needs to be publicly available, obviously, because else nobody could buy some services. And it's connected with the so-called contract management, which indicates the TM-Forum APIs with the trusted issuers list of the data space connector, so that we can automatically grant access for participants that bought access to, for example, our data service here. Now, let's again have a look how this looks when we will run it. Very similar to the consumer, we first have to create an identity for our provider. I will go very quickly through this because it's essentially exactly the same steps that we had before. We have to create the key, we have to create the public key, we have to create a certificate for our provider. Here we have to provide identity. We also have to package it into a key store and then create the ID from it. I made a mistake somewhere. Oh, probably here. No, so okay. Now this is now the identity of our provider, and we create also a namespace for the provider. And now we can go through the values YAML that we will use for our provider. We will not have as many disabled components as we had before, just the key cloak, because in this case, the provider doesn't have to authenticate itself elsewhere. Very often a provider will also double down as a consumer, so you might have also a key cloak configured here, but we don't need it in our case here where we have the provider just providing data. In terms of authentication, we will have first to configure the verifier. Similar to what we had before, the ingress needs to be explicitly enabled, and we configure where the ingress is available at, the verifier is available at, so provider verifier, and then our already well-known host. And we have to configure our verifier to connect with our trusted issuers registry, so that it actually knows where to ask for participants. And the verifier itself also needs to know its own identity, which it uses as part of the authentication step. Then we also configure the public address of the verifier here, because it needs to know it to provide it as part of the OpenID configuration that you have seen in the slides. And we can also configure it to connect to our credentials config service. So very much standard, not much to configure. Very important that we put in basically the trusted issuers registry address and also our identity. Configuration for the credentials config service is very easy. We just have to enable it. Everything could be used from the defaults. It doesn't even have an ingress or have to have an ingress, so we also don't have to configure anything here. Trusted issuers list could normally look the same. I enabled the ingress here because that makes it easier to show the demonstration later. But in a normal environment, you won't even have to enable an ingress for the trusted issuers list. So all you have to do is enable the issuers list itself. Both of them share their MySQL instance, so we have to provide a MySQL here. Since everything is also standard configured in the trusted issuers list in the credentials config service, we again only have to provide the right storage class to the MySQL, and then everything is configured there. Then we can go to the authorization services. One important, but I think often overlooked part is our data space config, which is here enabled. I added the defaults here because most people probably don't know what it contains, but you can configure what data models you support as part of your data space connector, what protocols the data service is available at, and what authentication protocols we are using. This will automatically translate it into a compliant JSON document and will be then offered through the well-known endpoint. Then the interesting component of the authorization essentially is our API6. To make it available publicly, we have obviously to enable the ingress here again. We offer it under this address of our data service to make all subsequent services available there. Then there is some default configuration again here, which I included to give a little more explanation. We configure a certain path below our host to be served by a certain service in the roots of our API6. One of them is the OpenID configuration for our data service, because that fulfills the contract of the data service to provide its OpenID configuration. We forward all of those requests to the verifier, and we rewrite the incoming address of well-known OpenID configuration to the OpenID endpoint configuration endpoint of the verifier. We do very much the same with the data space configuration, just that we forward it to the data space config service, which is the mentioned static file server. And we also again rewrite the address, and we set a header on the response to actually make all of it actually JSON file, so that our client will properly understand it. And then we have the last route, which is actually the most important one of RP6 here, which is more or less a catch-all. So every request to this our host that is not one of the two well-known endpoints will be handled by this configuration. We configure that those requests will be forwarded to the data service Scorpio, but only if they are contain a JWT token, which will be verified at our verifiers endpoint, and if our open policy agent actually accepted it as the PDP. This is configured to be at localhost here because, as mentioned, the open policy agent is running as a sidecar to our API 6. Then we can already go to the configuration of the open policy agent, which again is very small because you don't have to configure anything. You could just use the defaults here. We have the PostgreSQL that will be used by our ODRL PAP in the next step. Similar to all databases, we only have to set the storage class. Then we have to configure our ODRL PAP, which also has to know its own identity to make actually to reason, for example, about the rules, about the roles, and if they are applied to this participant. And we open an ingress here so that we can configure it in the demo environment. So you don't have to enable this ingress at all time. That depends again on your internal use case. And at the last step, we also have to configure our data service, which is Scorpio. And as I mentioned, it also needs a PostGIS. We provide the pre-configured PostgreSQL here. We only have to set the storage class again. What we do here is configure Scorpio to automatically register itself at the credentials config service so that it already accepts a number of credentials that we configure here. But this is also, again, part of the defaults just in this file to make it visible for you. And as a last step, we also enable the Teamform APIs. Here again, just to make them publicly available. And the contract management would also just use the standard configuration. So in general, the configuration of our even relatively complex provider is relatively small. It could be even smaller than in this file. But yeah, only to make you aware of it. Now we have to deploy it. We first have to, again, provide the key of our identity to the cluster as a secret, exactly the same as we did with the consumer. We also use more or less the same command that we used for the consumer for now deploying our provider, just with our new provider values YAML file that we have seen here. And as you can now see, it will just deploy a couple of more components. We will have, for example, all of the Teamform APIs that we have deployed. We will have our verifier. We will have the trusted issuers list. We have all the components connected to API6, which is also using an etcd. We have the contract management. We have the ODRL PAP, and we also will have our data service. The data service usually is the last one to start. Overall, starting the provider usually takes 1.5 to 2 minutes. So let me continue with what we have to do also to connect our provider to our data space, which obviously is registering at the trusted issuers registry. same way we did already with the consumer. Here. Now we have also registered at our trusted issuers registry, and both of them are considered participants of the data space. We could check if already a couple of things are running. So right now we are just waiting for Scorpio. Yep. We wait for Scorpio and for the Team API registration to be fulfilled. This is a job that automatically runs until it once finished, so the error is not important here. Everything else is already running, so that we can already start with some verification of our database connector. First, check if our open endpoints are available. Maybe I can copy this to a JSON file so that it's properly formatted and more readable. Yeah. So this is essentially what we get back from our well-known data space configuration endpoint that we have configured through the static file server. We now see here which models it supports. We see what protocols are supported and also which authentication protocol. The next thing we also have to check is our OpenID configuration, because this is what an actual consumer will use to connect our services to. This is the other thing that gets forwarded by the by API 6 to the verifier in this case. We can here see the issuer address of the token provider. We can see the authorization endpoint. We see the token endpoint of the verifier. It provides its JWKS endpoint, which is then used by API 6 to verify the JWT tokens. We see the supported scopes. Here the grant types, which is important for us in terms of our ID for verifiable presentation flow. So essentially everything that the consumer and its wallets needs to know to actually exchange a credential with our verifier when someone tries to connect our services. And then what we also have to do is so if we now want to allow our consumer to actually access the services that we provide, we have to configure it inside our trusted issuers list of the provider. That's why I said we also put the trusted issuers list of the provider at the public endpoint here, because we have to explicitly tell that this participant, our consumer, is allowed to issue those credentials in our context. We could configure it differently so that we trust every participant of the data space, but I would like to make the point that we have very fine-grained control from our data space participant on who is allowed to access what. So that's why we now will explicitly allow our participant to our consumer to actually access this. I just have to check where its identity was. This one. So we will now register it at our trusted issuers list. Now it's locally registered. And now we can test if our authentication authorization framework actually works. So first, we will try to access our data service. So we're now basically in the verification phase, and we want to act as if we are a consumer of the data. First, we need to try basically to access our data service unauthorized, so without any authorization header. Most of you will know this endpoint as this request as an NGS IID request, so we just try to get an entity here. Okay, Our API gateway now answered with 401 authorization required, which is what we expected. Therefore, we now need to create an authorization for the OpenID for verifiable presentation flow. We need a wallet for this usually, so I will create a wallet and a so-called wallet identity. I will not go into the details of this here because this would go into too much time. But it's very similar to the way we create an identity. What did I do here? I not change the. Sorry. Command is wrong. Sorry. We essentially create the identity the same way we did it for our participants. So now we have a wallet that also has an identity, which is essentially the identity of our user that acts on behalf of the consumer. And that's something that for a normal user, a wallet will take care of. But just for the demonstration, it's much easier to do it that way now. I think I also have to make the key available now. Yes. So now our key is available, and we can use the key that we created for our local identity to exchange the user credential that we created earlier. So I stored it in environment variable. You can see here. There. And I exchange it through the OID for verifiable presentation protocol with the verifier and get back a valid access token. This is going through this script, but that's also something I will go more into detail next week because we won't have enough time today for that. When I now use this access token to access my data service, hopefully it changed the response, and it happens exactly what was expected. So we don't have a 401 anymore, but we have a 403 forbidden. That means the open policy agent did not accept our request, which is expected because we didn't create any policy to actually allow our request. I have an example policy here that we will create. This will allow every request to a certain type of entities, actually entities of type energy report. You can see this here. To any authenticated user and for read requests. If you want to know more about ODRL policies, please have a look at the IAM session from 2 weeks ago. I talk about ODRL policies more in this session. Now we can do our request again with the same access token. And instead of the forbidden, we get an empty list, which is expected because we have a cleanly installed data space connector. And now we get an empty list. So this is essentially all steps that we needed to verify that everything's working. Just to recapitulate, we now have a trust anchor installed in our Kubernetes cluster. We have a participant that is a consumer, which can issue identity, which could issue credentials to its users. We have a provider installed that can offer a data service through the and this data service is secured through OpenID for verifiable presentations and through ODRL policies. And we have proven that the consumer now can access those data with issuing credentials to one of its users. Obviously, you can configure much more in detail on all parts of the components. But as I mentioned earlier, I would highly recommend to check the original charts if you want to do special things with certain components. But with just those relatively reduced values YAML files, you should already be able to set up a full data space and to fulfill the normal tasks that you want to run inside a data space. With that, we're essentially at the end of today's presentation. As Jason mentioned, I put all my presentations in the standard place of my presentations folder. Another important read is the Data Space Connect repository itself, which is linked at other points in the presentation too. And I think this question would obviously come. The demonstration that I did today is available in this deployment demonstration repository. So you could exactly do every command that I also did in my presentation.